Hello everyone, welcome to Tech Systems. In this video we will talk about variable air volume system, which is also known as VAV system. After watching this video you will be able to know what is a VAV system and how it works, what are advantages of a VAV system, what is a VAV box, what are different types of VAV systems. So let's start the video. A VAV system is an all-air HVAC system which uses variable volume of the supplied air while the temperature of the supplied air is kept constant. This is opposite to CAV system which we discussed in the previous video, where volume is kept constant while the temperature of the supplied air is changed. I will give the link in the description of CAV systems also. VAV system is commonly used inside modern buildings as it allows individual temperature control for the zones served by the same AHU. It is also energy efficient compared to the CAV system. Different rooms inside a building have different thermal loads. For example, a small office will have a less cooling requirement than a meeting room which have more occupants. Each of these rooms can be considered as a different zone with different thermal loads. A VAV system can serve different zones as per their thermal load requirements. To understand VAV system, let's take an example of a small office building which consists of 3 rooms. Here we have an AHU which is supplying conditioned air to the rooms through a supply duct. Return air from the rooms is taken back through a return air duct which is then exhaust to the outdoor, or in some designs part of this return air can also be mixed with the fresh air inside the AHU for energy savings. Conditioned air is supplied to the rooms through a VAV box which is installed inside the room above the false ceiling. After passing through the VAV box, air is supplied to the room through a diffuser. Air supplied by the AHU is at constant temperature, which is usually 13 degrees Celsius or 55 degree Fahrenheit, while the flow of the supply air is varied to meet the thermal load demands of the building. The VAV box controls the amount of the airflow to the room as per the thermal load demand of the room. A thermostat or a wall module senses the room temperature and then controls the VAV box based on this temperature set point. VAV boxes allow individual temperature control for all the rooms being supplied through a common AHU. For example, room 1 and 2 are being cooled while room 3 is being heated through a heater installed inside the VAV box. As airflow through the VAV box changes, it results in change of air pressure inside the main supply duct. For example, if VAV damper of room 1 closes, it will result in high duct pressure inside the main duct. Similarly, if VAV dampers are more opened to provide more cooling inside the rooms, this will result in low duct pressure inside the supply duct. So we must control the supply static pressure to maintain the designed value to ensure proper airflow to the rooms. To control this static pressure, a VFD is used to control the speed of the supply fan. A duct pressure sensor is installed in the main duct, usually at 2/3 of the duct length. This sensor provides the static pressure value to the DDC, which in turn controls the VFD to maintain the designed set point. Static pressure set point is provided by the HVAC designer or by the air balancing team to ensure proper airflow through the system. Power consumed by a fan is directly proportional to the flow cube value. So when less airflow is required, speed of the fan is reduced, which results in less consumed power and energy is saved in the long run. Now let's discuss about the VAV box in details. A VAV box consists of a damper. This is a butterfly damper. I made a complete video about dampers. I will give the link in the description. Then we have an electric heater or a heating coil. This is optional and is used in more cold areas. Then we have a DDC controller to control the VAV box. This controller have a built-in motorized actuator to control the opening and closing of the damper. Then we have an airflow station. This station senses the average velocity pressure across the duct area, which is then provided to the DDC through the two pipes. DDC senses this differential pressure and converts it into the flow value by using the duct area. Airflow through the VAV box is controlled by opening and closing of the damper. When more cooling is required, damper is opened to achieve this demand by increasing the airflow to the room. Now let's discuss about different types of VAV systems. We have two types of VAV systems. First one is pressure dependent and then we have pressure independent system. Let's talk about pressure dependent system first. In a pressure dependent VAV system, airflow through the VAV box is dependent upon the duct static pressure. VAV damper is controlled from the zone thermostat based on the temperature without regard for the system conditions. Resulting flow through the VAV box at any moment is very dependent on the system pressure at that moment. In this system, two zones on the same supply duct are affected by the control of each other. Pressure dependent VAV box is shown where a damper is controlled through a motorized actuator by a thermostat. Damper is directly controlled by the thermostat based on the temperature set point. A minimum open limit for the damper is defined, which is usually 30% to ensure proper ventilation in the room. To understand pressure dependent system, let's take example of two rooms being supplied by the VAV boxes. One room is an office and the other room is a meeting room. Currently both rooms are occupied and dampers of both VAV boxes are fully open to meet the cooling requirements of these rooms. After some time, meeting room has few people remaining, which results in low cooling load in the meeting room. Thermostat of the meeting room senses this low cooling demand and partially closes the VAV damper. As VAV damper closes, pressure inside the supply duct increases. This increase in the duct pressure will result in more airflow to the office room. Temperature of this office will decrease due to this high airflow, and after some time thermostat will sense this decrease in temperature and will command the VAV damper to close in order to achieve the desired temperature. So as you can see in this example, the flow to the each room is dependent on the system static pressure. That's why it is known as pressure dependent system. In this system, opening and closing of the VAV damper of one zone affects the flow to the other zone. Now let's discuss about pressure independent system. In this system, airflow through the VAV box is independent to the system static pressure. In this system, airflow is monitored at the inlet of VAV box. Damper is controlled by the DDC controller through an airflow reset control loop programmed inside the DDC. This control loop responds to the changes in the system pressure and thus adjusts the damper to keep the airflow through the VAV box constant. For the given desired temperature, if the airflow is insufficient, DDC will further open the damper. Similarly, if the flow is more, then the damper will be closed to get the desired airflow. Here we have a pressure independent VAV box where we have an additional airflow sensor. This sensor provides airflow value to the controller, which then controls the damper actuator to maintain the airflow through the VAV box. Pressure independent VAV box have a maximum and minimum flow limit. DDC maintains the preset flow between this limit as per the cooling demand of the room. Maximum airflow limit prevents excessive cooling and excessive noise in the occupied space, while the minimum airflow limit ensures proper ventilation is maintained in the room. Consider the same example of an office and a meeting room, but this time we have a pressure independent VAV box where an additional airflow sensor is installed inside the VAV box. This airflow sensor provides the airflow value to the DDC, which then controls the damper to maintain the airflow through the VAV box as per the cooling demand of the room. In this situation, both rooms are fully occupied and the dampers are fully open. After some time, few people are left in the meeting room, which results in low cooling demand, and as a result, VAV damper is partially closed. This partially closing of the damper will result in high static pressure in the supply duct and flow to the other room will increase. VAV controller will sense this increase in airflow and will immediately adjust the damper to maintain the airflow set point. So as you can see in this example, the flow through the each VAV box is independent to the system static pressure. In this system, damper position is adjusted to ensure that the required airflow is flowing through the VAV box.